Okay, so I think we stopped at the right place and we are starting off from that place, right? So Rudra was giving a nice tutorial on basics in LLMs, right? We started with basic promptings and then we went up to this part of agents, right? Now if you actually look around you, it's agents everywhere, like water everywhere, right? So,
we cannot hear you.
Oh, did we unmute or something? Did we not unmute? I'm not sure. I think I am audible now, correct?
Yes, you are.
Yes, great, thanks. Great, thanks. Okay, so I was just mentioning that like water everywhere, we are talking agents everywhere. Everywhere you go, people are talking about agents, right? Of course, there is a hype factor to it. There is some good aspects to it. Of course, there is always a good, bad, ugly aspect to it, right? So for example, one of the initial works came from Microsoft, something called AutoGen, right? They released AutoGen and everyone started talking, okay, we could use this to build, amazing stuff, right? And some of this example that Rudra was also showing. Then recently, yeah. Should I stop or? Okay. Okay. Yeah, that's fine. Control L, please. Yeah, so recently Satya Nadella, in one of the podcasts, he mentioned this. He didn't explicitly state as such, right? I mean, SaaS is dead, right? And that created a lot of issues among companies saying, oh, now what will we do for our living, right? Is software as a service dead? He didn't exactly mean that SaaS is dead. I'll try to cover that as I go along. Then, for example, OpenAI created something called Operator, where it will automatically go through whatever you want to click. It will click all that, perform task on behalf of you, right? Or Cloud created Computer. Satya in his recent talk was talking about open agentic web, where he was talking that everything becomes agents, right? And Microsoft apparently is working towards it. And then, of course, you have this kind of, Harvard Business Review articles coming up saying agentic AI is already changing the workforce. How many people are going to lose the job? So there is a lot of hype, and I want to cut the hype here, right? I want to focus in this session on a little bit of what is this all about, and more of how can we leverage this for software systems and software engineering and so on, right? So extending on what Rudra said and what we have been discussing in the morning. Because in the morning, I was talking about AI for self-adaptation, right? That's only one aspect of it. But here I'm saying, okay, within AI, we covered some angles, but what about generative AI? How is it helping, right? Not just from runtime perspective, it is also going to help from design time perspective. When you build a system versus when you run the system, right? So we'll go through the entire system lifecycle. So just to give some, this is something we all know, but over the years, AI has kind of evolved, right? And the evolution initially was very slow, but then it evolved very rapidly over the last decade, very, very, very rapidly over the last few years, right? Nowadays, it's like, oh, I have done this 2 years back means that it was very old. But that's the way in which AI models are coming up and things are changing, right? GPT 3.5 came, 2022-ish or something? And from then to actually look at the capabilities today, it's much higher, right? We have significantly progressed. When initially GPT came, people said, this is not working, it's hallucinating, it's not giving me correct responses. To the fact now today we are talking about, yeah, it seems to work for most of the cases. These cases, it's not working. So we have actually shifted. Our mindset is also shifting, right? This is thanks to the fact that in 2017, there is this interesting work that came out, right? What was that work? That kind of revolutionized the whole space. It was not just the work, but coupled with computing abilities and everything, but there was a work that said, oh, this is great. 2017, anyone? Yes, attention is all you need, right? So there was a paper that came which actually made people think different. Now, what is this all about? See, one of the fundamental problems that we have been chasing, right? If you look at AI, it's all about how do I create something which can mimic human behavior, right? And one of the problems we have been chasing forever is, can I predict the next word? That's it. Very simple problem, right? Given a bunch of words, can I predict the next word? So if you go to Google today and search, what is software? It will say, what is software? What is software engineering? What is software testing? So all these bold words are predicted words, right? Based on what you have put, correct? And I can say software engineering is, it's already saying dead. Okay, that's what Google said. I just took the screenshot. Yeah? Or if I put something in, in a language, in English, it might say something in Italian, right? It is now here, it is trying to understand and trying to give the translated version of it. So I still need to understand the word. So this has been a problem since 1950s, right? And there is a quest for artificial intelligence where can I predict the next word, where the systems understand, generate the words and so on, right? And we started with, it's been a long journey, right? Because we started with something called, very simple Macula-Pitts. MCP doesn't stand for Model Context Protocol here, right? That's what people are talking about. I'm talking about MCP model, which is the first neural network, okay? That came from in 1943 by two people called Macula and Pitts. They said that if you just have a single neuron, you pass input, it will apply some function and produce an output. That's it, a basic neuron, right? That's the first artificial neuron that came. Ever since we have been like, okay, I have a bunch of neurons that are connected to each other. If I give a set of words, can I predict the next word? So if I say software architecture is about, it should predict something called components, right? And this was possible in some sense by using your traditional RNNs, right? And then LSTMs came, so you were able to do that. What happened is, what was the observation? As you increase the number of these previous words, when I want to understand the context based on which I need to predict, sometimes the models were not able to do that because how much of memory I need to store so that I can predict the next word more accurately. For example, if I say software architecture is about components, it might predict and because that could be logically the next word. If I give and, it might say connectors. Now this because it could refer to software, it could refer to architecture, it could refer to components, it could refer to connectors. Humans we know, right? When we say, a dog is an animal, it is also a pet. I know it refers to dog, right? But that's not the way computers understand. So this was becoming difficult. So that is when this paper, I'm just giving a very basic definition here, so to keep it very simple. So this paper came up with this idea. Although attention was not a concept that came in 2017, it came in 2015 in one of the paper, right? They came up with this idea of self-attention networks. So this paper, what they said is, all you need is attention, where attention is about how much a word needs to know about the other words. Like for example, if I say it, if I need to know what does it refer to, I need to know its strength with respect to all the other words that I have in my dictionary, right? For instance, if I know that it is more strongly connected to software and architecture, I know that it actually infers that, right? So which means if I have a bunch of text in the world, what I can do is I can give it to some kind of a model. Don't worry about what that model is. The model can try to infer the relationship between all different combination of words. And it can say, if this is the word, most likely this word should have more connection to all these words. Now from this, can I predict the next word in a much better way, right? So this is the whole idea. This idea was translated to saying that, okay, now if I have a bunch of text, can I predict the next word? And if I constantly predict the next word, what does happen? If I give a bunch of words, I predict the next word. Then I give all those bunch of words, I predict the next word. If I continuously do this, what will happen? It won't train. If I constantly predict this, you will feel that I am generating a text rather than a word. But all I am doing is I'm predicting the next word, right? So if I say software architecture is, it will predict about. If I say software architecture is about, it will predict components. So if I keep feeding it back to the same system continuously, what will happen is you will feel that a bunch of text is being generated, but actually what is happening is next word is constantly being generated. This is what today all the LLMs are very much capable of. And how they are capable of it? Probably what was done is I throw in all the 10 billion text from the internet, right? More or less. I take all the text that I have from the internet, I scrape the whole text. Because now if I take all the text, what does it mean? I am able to capture some kind of a semantic relation between all different words that I have, right? If I use it, what are the words I might use? If I use was, what are the words I might use? So all this possible combination I'm getting from all this text, right? And I'm passing all this text to this transformers, where transformer is of course a neural network architecture, so I'm not going into that. That's a paper that I was talking about. So I'm passing it to this. Now of course, if I am passing so much of text, I cannot just train the model on some small computer in your laptop or something, right? It has possibly millions or billions of parameters. Now what is a parameter? I'm sure you know that, right? So I pass it to a transformer, right, and probably train it for days, and it is running on multiple GPUs, and what I get out of is some model. Now this model is a basic model which has some understanding of the world. Okay? It's not a complete model yet, right? It's a base model or something we call as a foundational model, right? It has some understanding of how the relation works. So given something, I'll be able to throw out something because I have some understanding of the whole relation. But it is not very specific to any domain because I've just taken all the internet text and I feed it to some neural network and say, okay, now you know all the relationships in the world, now try predicting next word. So it might even blabber something because it may not exactly know what domain you're talking about, right? So now, which means that the next point is, how do I make it very much optimal for what I want? Correct? Because you have a base model. Now what do you do? I'm saying, okay, let me create something very specific to software architecture because I want my model to be very good with software architecture. So at this point, what you do, you take the base model and you fine tune it, which means you put information which are very specific to your domain and add on top of it in such a way that it will be able to provide responses very much catered to your specific domain. Okay? So for instance, in software architecture, I might ask questions like, hey, for example, what is software architecture? I might want to say, okay, software architecture is a combination of elements, form and rational. How to start thinking about architecture? It might you want some other answer. Like that, you create bunch of samples. When I say bunch of samples, it's not like, 10 or 20. It's like hundreds or thousands of samples you create. And you are saying to the model now, okay, fine tune yourself with respect to this particular domain. Now this is very similar if you want a real life analogy. You are a bachelor student, you have all the information in computer science, right? Now you are like a base model. You have knowledge about many things, but not deep knowledge about something. Maybe you tried by your own, but you don't have probably a deep knowledge about something. But then you become a master student, an MTech student or an MS student. And you specialize, for example, in software engineering. Now your knowledge about software engineering is more deeper. Right? So I have fine-tuned or you have been fine-tuned on software engineering. So you say that I'm a computer science student, but my specialization is software engineering because I'm taking so many courses related to software engineering, I've become specialized. So that's the whole idea. Okay? So some of the examples are, there's something called Codex GPT, those are initial stuff, right? There is something called CodeBird, Codex GPT, because these are programming models. I fine-tuned a foundational model on programming data. I scraped all the GitHub data, I give it as examples so that given a program snippet, I can generate the complete program for you. If you actually go to Visual Studio Code today and you start typing something, it will automatically generate the program. You don't have to type everything. You just need a GitHub Copilot with you. Correct? So today, if you look at it, these are, so this LLM space is flooded, right? There are so much of providers, so much of, if I was giving this talk 1.5 years back, I had given something similar. I don't have so many, at that point, there were not so many LLM models. Now you have been flooded. On one side you have proprietary models like Anthropic, right? Creating cloud-based models. You have Gemini, which you used by Google. Then you have OpenAI's ChatGPT. You can use that also. Of course, you have to pay for it, right? Then you have open source models. Imagine that, for example, hey, I don't want to pay for all this. What will I do? Yeah, you can take an open source model and run it. But where will you run it? Either you have to run it in your machine, but for that the model has to be smaller so that you can run it in your machine. So you have to use called quantized models, like small models that can run in your machine, right? Or you have a big server. You can say, hey, Karthik, I have 20 lakh server that provides some great crazy GPUs. Put it in that, you will be able to. You can take a Llama that is available and make it work, right? And you can also run fine tuning, but that's a little tricky depending on the GPU you have and so on. So today you have Hugging Face. If you go to Hugging Face, you have a bunch of LLMs that are available. You can go to, there is something called Mistral that came from, right? That's another open model. This, what is this? Yeah, DeepSeek, right? The famous DeepSeek. Suddenly everyone started talking about it, right? So DeepSeek came from? Yeah, okay, that everyone knows, yeah. So DeepSeek is it's a model that kind of came up with a little different architecture in how it was actually performing the learning and I was splitting out words, right? Then what happened is over the years, you have also, over the last 2 years, I've also have many frameworks. Someone was asking me after the tutorial, how do I think of building agents? Yes, you can either use, simple ways, as Rudro said, do a simplistic way where you use an LLM, make it to perform some task. If that is not working and you see that it's getting more complicated, you want to use a framework that can help you. There are a bunch of frameworks available like AutoGen, CrewAI, LangGraph. Some of these are open source. Most of it is open source. You can just use it. And then you might be asking, okay, Karthik, this is all great, so many LLMs, but how will I select what LLM I should use, right? So for that also somehow, the problem is, not solved, but there is an aid for you. You can go to this community leaderboards like LM Arena, right, or SWE Bench. If you are using LLMs for software engineering task, you can go to SWE Bench and pick one from this. Or you can go to this LM Arena and pick what is the best one available. See, for example, Gemini 2.5 Pro is the one that is leading when I was taking a screenshot of this a few months or 1 month back. And also for different tasks. See, this is for text generation. For web development, there is another, leaderboard. So for every task, you have an LLM. See, it's not one size fits for all. We need to understand this. One can be good at something, some other thing can be good at something else, right? So this is something we need to understand. So now let's go into having said that context, right? I hope there is some context for you now. So let's go a bit into the world of software engineering, right? If you look at software engineering, there is a standard development SDLC, software development lifecycle, right? It starts from requirements, then you have design, then you have development, then you go to maintenance, testing, deployment, and this keeps continuing. This is a usual thing that we do. So what we said is, how much can LLMs help with respect to this SDLC? And there are a lot of works. I'm not saying that we are the only people who are doing this. There are a bunch of people who are doing this. We are also one of the groups who do a lot of research in using generative AI for software engineering and software, particularly software architecture, right? So what I'm going to do now is, since there are, again, LLMs, textbooks applied to software engineering are very less, we are going to take inspirations from the research we have been doing. Over the last 2 years, we have done, or 2.5 years, we have done a lot of research in this space. So we'll talk about some of the works that, how it has helped, and probably how you could think of using them when you're building software systems. So you remember software architecture. We had a discussion about it in the morning, right? And I said one of the important aspects of a software architecture. So if you look at this is a diagram. This is an architectural diagram of a simple internet banking system, okay? In internet banking system, it says that, okay, there has to be an email component, there has to be a single page application, there is a mobile app and all those details, there is a database, email system and so on. Now, what is an architecture from this diagram? You can say that architecture is nothing but a combination of all these components, which are these boxes, the connectors, which is this API calls, how they are being called and so on, and the decisions. For example, why did I choose Spring? Why did I choose this particular component? Why did I choose, for example, mobile app being done in a particular React Native technology? All these are decisions that I'm making. So if I capture the set of components, the set of connectors, and the decisions, it means that I can capture the architecture of the system. Okay, there is some problem here. Okay. So there is an interesting paper. I'm not going into the details of it, because it's not very much appealing for this audience here. But what I want to try to say is that what is software architecture was always a question to the community, right? Everyone used to ask, what is software architecture? So some people said, oh, it's just some diagrams, some blueprint. Some people said, oh, you know what? It is not about all this. It is about, capturing the organizational aspects. What kind of company you are, what kind of technology you like. So there were multiple definitions for this. So in 2005, a very interesting paper came which just said that software architecture is nothing but a set of design decisions. Where decisions are, something you can think like, hey, I want to use microservices, or I'm not sure if I should use a monolith. What do you pick? And why did you pick that? So this decision. So if you capture all these decisions together, it means that you have got your architecture. Now, why this is very important definition? This is a very important definition because one of the biggest challenges in the industry today, and I'm sure I know some of you are from the industry. How many of you are from industry? If you could just raise your hands. Okay, great. I think someone in the audience as well. Great. So one of the biggest challenges, especially in the software industry, is one is related to something called migration. If I have a very old legacy system, how do I migrate to a modern system? That is definitely there. Other thing is, which is very much connected, is most of my systems does not have any architectural documentation. No one has documented why something was done in a particular way. Because if I know why something was done in a particular way, it is easy for me to modify it or do something on top of it. But most of the time, this is not there. Why? Because what happens is most of the time the documentation is in the head of the architect or bunch of people who actually made the decision, right? And when this person leaves the organization, they also carry the knowledge along with them. And probably these are conversations that they would have done with their colleagues. Nowadays we have Microsoft Teams, Google Meet or whatever. So probably you could record these conversations and do whatever you want. But olden days, mostly it's just, hey, I think we should use Spring because this is the reason. It happens over a cup of tea or a coffee, right? No one is capturing this decision. Now it is gone. And this process or this problem is called knowledge vaporization, where a person goes, the knowledge also evaporates, right? And a new person joins and there is no clue why something was done in a particular way. So this calls for a big challenge, and the question is, what can we do now? So many people worked on this, and this area of research is called architectural knowledge management, where the idea is, how do I capture this knowledge? Now this you can translate to any knowledge management, not just software architecture. I also know that knowledge management itself is a big research area. Knowledge management, knowledge discovery, and so on, right? So the whole idea of architecture knowledge management is, can I have some way by which I can codify and maintain this knowledge consistently as my system evolves as well, not just I do it for once, right? And it's a very challenging problem. Why? As I said, this is not available anywhere, right? This is not properly put somewhere and from where you can easily extract it out. So what do we do about this? So very interesting paper came, 2016, 10 years of software architecture knowledge management and where we have reached. Interesting thing is, not much. Because whatever you propose, industry will come back and say, hey, this is very hard for us to do. Because researchers, we are all like, we'll come up with some fancy ideas, which may not be a practical stuff, right? Because we are thinking in a different way, industry is thinking in a different way. They want probably simple tools, but we are building little something complex. So this was not working. And also there was not many mechanisms that could automate the whole process, because at that time, even AI was not very advanced if you want to use, if you ever wanted to use AI also. So the question was, what could we do, right? And in 2023, I was attending a keynote by a person called Paris. He's a big professor in this field of software architecture knowledge management. He said, why don't we do something called Arc boards or a Copilot, where this Copilot could be something that could mine out architectural knowledge from your system source code repository. Because ultimately, you will have at least a source code repository where you'll store the system. Now, can we do reverse mine the information and the knowledge from that? That was the question we started with. And that's when, at that time, around Rudro joined for PhD, and he said he is also interested, and I mean, we had a lot of discussion. He wanted to do something that has, some relevance in the industry, and he said this is also one big problem that he has been facing in his company when he was working. So based on all this, we said, let's dive into this, right? And we came up with a very initial work. Again, I don't want to get into the details of this, but much of it is this, right? If I have a way by which I can extract out the architecture knowledge from all the things that I have in the world. It could be a bunch of repositories, it could be blogs, it could be YouTube videos. There are this architectural knowledge information in terms of how an architecture should be done, what kind of an approach you should follow are all available in the internet, right? There is a lot of gray literature, there is a lot of white literature and so on. So we said, can we take all this information, whatever is available, and create a world knowledge kind of stuff, which is very specific to software architecture. Now, which means you can think of it like someone who knows almost everything about software architecture in the world. Now this person is joining a particular organization. Now when I come to an organization, that organization will have its own constraints. Like for example, we are an Oracle driven organization, we are a Microsoft driven organization, or we are a Google. I saw someone was in G Suite, right? We are a Google driven organization. So can I now take that organizational information, augment on top of what I have gathered across the world, and do something very specific to that particular organization? If I can do that, it means that I'm able to solve the problem, or at least attempt to solve the problem, right? So that's essentially the idea, where we say that we retrieve all the knowledge that is available from the world, but we create something very specific for that organization, because we will try to understand the organizational principles, organizational practices, probably from their code repository, from their meeting notes, whatever. And based on that, we will suggest something. So we have knowledge of the world, we also have knowledge which is very specific to the organization, and we will recommend practices and so on, right? So this was the whole idea. So we have to start somewhere, because this idea is great. We have a nice research paper. Paper was published, but that doesn't mean anything, right? Because where do you start, right? You have to start somewhere. So we said, where can we apply this? So interestingly, one of the way by which software architectural decisions are captured is through something called architectural decision records, ADRs, right? Why these are captured through this? The basic idea of an ADR, it's a very simple, lightweight markdown documentation mechanism. So you just take a markdown, quickly jot down something in a particular structure and put it. So that the problem that architects are facing is, if you ask them to do extensive documentation, they don't have time. But instead I'm just saying just-in-time food, or like 2-minute Maggi noodles, right? You just quickly document something, you put it there. That was the whole idea. So there are a bunch of ADRs that are available in the open literature. So first thing we wanted to ask ourselves is, can we at least use LLMs to generate ADRs, right? But that is also a big task, because generating an entire ADR means Usually it has a format like this. For example, I give a context. We need to decide whether to use Python as a programming language or probably maybe R as a programming language. Imagine that you have such a dilemma. Now you need to decide. Usually what the architect do is they'll say this is the context in which I made the decision, and the decision I made is I'm going to use Python as our programming language, and I have a bunch of reasons for it, a rationale for it, and there is a status which says decided, in progress, proposed, and so on. Right? This is the usual template. So what we did is we said, given a context, can we generate a decision? This was the question we asked ourselves. With the current capability of LLM, when I say current capability, this is 2 years back, right? 2 years back. Because current is already gone. That is the space in which LLM development is happening. 2 years back, we asked this question. Can we generate decision given a context? Okay. So we performed a exploratory study where when we say exploratory study, these are studies that are mostly, the whole idea is to explore a particular emerging field, right? That's when we do exploratory studies, right? We wanted to explore the capabilities of LLMs for generating ADRs, particularly decisions given a context. So how do we do this study? These studies have to be conducted in a very, very methodological way. So we followed empirical software engineering guidelines for this. So what we do is you have to define what is the goals, what are the research questions that you want to address, what are the LLMs that you are going to select. You cannot randomly say, I like ChatGPT, I selected ChatGPT, or I like Gemini, I selected. No, there has to be some reasons for it. And we have to identify on what data you need to perform all this study. So this has to be methodologically done. And we had a procedure where we said, let's first do zero-shot prompting, where you just ask a question and say, okay, this is the context I have, give me a decision. Can the LLM generate it? Next is few-shot. Did you understand few-shot today when Rudra was giving the example? What can be a few-shot in this context, anyone? Huh? No, that is zero shot, right? I'm not giving any samples. But what is few shot? You already said the answer. With minimum. Some samples, some sets of samples where I say this is a context, this is a decision. Context, decision. Now given a context, give me the decision, right? That's it, very simple. So I'm trying to give LLM some idea on how it is mapping context and decision, right? That's it. Okay, I don't want to get into the part too much about it. And then we have finally something called fine tuning, where we take a bunch of existing ADRs and we fine tune a model and say now how much it improves. So this is what we essentially wanted to do. Clear, right? This was what we did as a study. Of course, the study is published in ICSA 2024. It's also becoming very popular these days because it was one of the first studies in this space of software architecture to follow a particular methodology and do it this way. Now people are adopting our methodology to do studies in this space. Yeah. So kudos to Rudra for the work. So what we did is we selected LLMs, right? First we had to select LLMs. So we used all these different criteria. We wanted to select LLMs of different sizes, proprietary, open source, right? And also encoder, decoder only models. So all these different things we selected. And we also had to, so this is very intentional. That's why I have highlighted from small to large models, because we also want to say, see, software engineering or this part of domain is a very critical domain if you actually look at it. Because if I am a software architect, you go to any company and say, will you be okay to share your source code to someone over the internet? You won't do that, right? You are very careful, especially if you are a financial company, bank company, you'll be like, I cannot even show you a single line of source code, right? So in fact, we are working with a bank, it's very difficult to get anything, right? So if I want to say, oh, use ChatGPT, they will have their own concerns. Every bank is trying to develop something for their own. So we also wanted to see if I want to do something very small that can run in your laptop or run in your local server, how good is that? Right? That's why we had to select small models as well. But it was not an initial thought, it was an afterthought. I mean, when we finished it, we found out that it is great. Yeah. So what we did, of course, we had multiple scores to evaluate each of this model's capability. So idea is very simple. You have a bunch of ADRs that you have selected from the internet. Now you have context and decisions for all these ADRs. Okay, this is your data set. Now what we do is we just give the context, we get the decision out from the model. Now we check that decision generated by the model with the original decision. Okay, and how do we compare this? We use a combination of metrics, right? Of course, here more relevant one can be the BERT score because it also uses the semantic similarity to say whether how good it is. but we also used other scores. Again, this also is becoming a contribution because many people are now adopting this combination of scores. Why you have to use combination? Because it's better to use combination because you will understand how is the structural similarity, semantic similarity, order in which the words were generated. All this you can get from different scores. Okay. So one important thing to highlight here is when we fine tune something like a Flan T5 base. So Flan T5 base is a model that you can just take from Hugging Face, right? You can just put in your laptop. Okay, so we fine tuned this model and it was performing, if you actually look at it, very close to a GPT-4. Okay, and this was a great result because you can run a very small model for a very specific task, which is a fine-tuned model for software architecture task, and it can perform as good as a zero-shot large model, right? That's the significance of the result, which means that now we can essentially tell to the orgs, maybe you can fine-tune your own, systems information and create your own fine-tuned model, and it can perform closer to the large models available outside. You don't have to depend on proprietary models. It's a privacy, preserving stuff. So this is a study repo. You can see all these 18 models have been benchmarked, for example, here in the BERT score here. And we can see that you have the different, colors actually representing few shot, fine-tuned, and zero shot. And you can see here, right? I mean, for example, we didn't fine-tune GPT-4, partly because of the fact that at that point, GPT didn't provide the functionality to do fine-tuning, the API for fine-tuning. Also, it's costly, yeah? Let's be honest. When we fine-tune, we have to pay, and we end up paying a lot of dollars, yeah? It's not easy, yeah? So we know how to fine-tune, but whether to fine-tune or not, and also most of the time you don't need to fine-tune also. This is something people get it wrong. Everyone suddenly say, oh, let me fine-tune a model. Most of the time with some examples or zero-shot things may work. So you might want to do some kind of experimentation. That's why prompt engineering is becoming a big thing. You just want to prompt and see how it is working. Anyway, I don't want to call it engineering per se. Yeah, okay. So, but one thing we observed is there is a need for more data and context because at that point the amount of data samples we had was very less. So one thing we said to the community is we need more kind of sets so that we can improve the model's performance, right? So yeah, these are some nice, quick images of decisions generated. You can see FewShot kept blabbering, so I had to cut it off. I couldn't even put it in a small box here, right? It was going beyond the limit. So I had to put some dots. Essentially, it has even generated more text here. But you can see a fine-tuned model was able to just say that, okay, the same question, whether I have to use Python or not, it just says that it will have a large data set, lot of data. So we need to use Python because of the projects, because all of our projects will require Python to use it, whatever, right? It was giving very nice result when compared to GPT. But GPT, of course, provided information like it can even help with integration to other libraries and so on, right? So that's always there. But what essentially I'm trying to stress is when you compare to the ground decision that was made, a fine-tuned model was able to provide almost closer result. So at that point, the RAG was not, it was just getting popularized, right? So I don't know, how many of you have heard of RAGs? Yeah, anyone can explain quickly what is it? What is RAG stands for? Awesome, yeah. So what does that mean? Retrieval Augmented Generation.
So actually, we have some data sets with us, and it retrieves from that particular documents or the data set, and then it is trained. The model is trained from that data set.
Trained is not a right word. Learning is also a dangerous word. Kind of. Then. Correct. So there is an LLM. You don't want to share the data with LLM. You have some private data. Okay.
So you want some information from that the LLM will help using the right.
You are almost getting there. So that's not essentially. More or less, right? But yeah, that is where RAG could be used definitely. But that's not RAG, right? That is where it could be used. The why of it, yes, but that's not the what of it, right? See, it's a retrieval. I need to retrieve. Given something, I need to retrieve a bunch of text, right? Go back to the old information retrieval. It's not something that came now, right? So if I have a text, I want to retrieve similar text from a given corpus of text. What do?
I refer the old documents.
No. I have a text. I give a text. I want to retrieve similar text from a corpus of text. So corpus, like you have a big corpus where you have bunch of text. Now I give a text as input. I want to retrieve some similar text. What will I do?
From the LLM.
Hey, LLM does not exist, man.
Information retrieval system.
Ah.
Some vector matching, very vector and data set.
See, it's very simple, right? If I am able, if I am, some very simple thing is string. If I have a string matching, I can do something. But now string matching is very deterministic. It has to be exactly the same, some uppercase, lowercase. You can write a regex, for instance, and get back. But I want to be little more, let's say, semantically similar things I want to retrieve now, right? So I might not be able to go with the same string matching or regex because it doesn't serve the purpose, right? Because, for example, I might say, I like Surathkal, right? Surathkal is a nice place. Both are probably meaning the same thing. But if I am exactly going with a regex or a string matching, it may not be able to fetch it. So I need this both to be captured in some way, right? So that is one aspect. So I need to capture. So what can I do? If I can represent, what does computer understand in the most simple way? Tokens. What is the base of computer? Let's go back. Numbers, right? Everything is binary, right? So which means on binary, on top of that, I can build numbers. So which means if I can represent some numerical, I can represent a text in a numerical way where the numerical aspect or the representation can capture the semantic relation between the words. Forget about the words here. People will, let's not use jargons. Keep it very simple, yeah? If I just have a numerical representation of a word, a bunch of words, that tells me some relation. And given a text saying that, okay, does Karthik like Surathkal? Okay? And I have already said two statements. Okay? And if I can convert those two statements into some numerical representation, all I have to do is, the question that I ask, how closer it is to one of this representation. Which means, you have a bunch of numbers, you have some bunch of numbers for each of. How do you understand if they are closely related or not? You can use that, or you can use Euclidean. Yeah, you can use Euclidean distance. See, that's it. Okay, so in this way, what you do? You retrieve. So you retrieve the related text from the given corpus. Okay, you retrieved it. Now what I did say, the one part is retrieval. What is the next part? You are augmenting and you are generating. Okay, so what you are augmenting? You want to say that, okay, I have retrieved this text with respect to the question Karthik asked. Okay, and now two things as input. I want to generate what should be the response for this given question. Okay, so for example, if say, does Karthik like Surathkal? I want to say, Karthik says Surathkal is a nice place, he likes it a lot. Something should be the generated output rather than just giving two texts that just matched. Okay, so this is the whole idea. So in order to just simplify, yeah.
But the problem will be like if we just check the closeness of the words, so every time we prompt the LLM, it should answer the same. But we get different answers
Correct.
every time.
That's the whole point, right? It may not always. So there are ways to address this, but just to tell a simple idea, if I have a bunch of text, in this text, imagine that I have talked about so much about Surathkal. It's a big paragraph. Okay, it might retrieve something which is not relevant to what I asked. So what you do is you only pick those which are very close, which has more higher closer similarity, and you will generate on top of that. But here also there are potential ambiguity that can happen, right? And here also it might retrieve a different set of text. Correct? So based on this, what will happen is your generation goes for a toss. Now it can also happen in terms of, I don't want to get into it, but in terms of what kind of settings you have with the LLM itself. Right? Whether the LLM itself is set in a particular way or in a different way. There are parameters, right? Temperature, top K, top P, right? How much words I should look up in order to generate the next set of words. So all this will have a role in it. Okay? So here is a simple example. I have to represent, I've already conveyed it, but I have two things like software architecture, it's about components and connectors. I also have something like software architecture is about forms and elements and rational. So I create a numerical representation, forget that terminology for now. Okay? And I'm storing this in a particular storage space. Okay? And from this storage space, what I'm doing is if I'm asking a question, I'm saying that these are the two matching documents, and I'm generating a nice response saying that, hey, software architecture is about components and connectors, it's also about forms, elements, and rational. Okay, this is something I generated. Okay, I don't know if GPT will generate the same thing, but I'm just giving an example here. Okay? So yeah, so the question was why not RAG? Okay? And the answer we did was, yeah, we could do that as well. So we built something called an R Copilot. That's a tool, right, where it was more like a companion for architecture. It's not really published or anything, just an internal tool we did as a bachelor thesis project. A bunch of students did a very good job in building it though these are the students who were involved, right? Of course, Rudra was guiding them. So where people can add knowledge, you can query for knowledge, it will generate decisions on top of what you asked, based on what you asked, based on the list of data it has, right? So all this was possible. Yeah, we are still trying to improve this, so this is not a fully mature tool yet. So once we went after that, the next part that people are very interested is, yes, LLMs can, up to a certain threshold, they can generate decisions. We are still working on it. Next question we had is, if it can generate decisions, can it generate the entire, component by itself? So we said that software architecture is about components and connectors, and I'm able to generate decisions. Now, if I can generate decision, can I generate the entire component itself? Can you tell the LLM, okay, you choose, microservices for this? Can you generate the microservice itself? Right? That's what we wanted to do. So if you look at today, there are different ways by which you can build software systems. As I said in the morning, there is monolith microservice, and today we also have serverless. So if microservice, for example, one service might have two smaller functionality in it, serverless means that every functionality becomes a deployable unit. So we said, let's start the work by saying, can LLMs be just used to generate a serverless function? So that's the smallest unit of a component in a software architectural sense, right? So what we did is we took inspiration from this it's not exactly the same, but just an idea, analogy, is from this concept of masked language modeling, right? Where given a text, you mask one particular word and you ask the language model to generate that particular word, and you see how closer the word is with respect to the masked word. Okay? Now the same thing we kind of did for this, but this is mostly used for training. Here we are using it for inference, which is in runtime, in real time we are doing this. What we did is, we take an LLM, we give a bunch of serverless functions. So typically if you go to code repositories of serverless functions, there will be multiple functions that are written. What we will do is, we will mask one function. We will give the context by giving all the other functions in the repository, and we will say, now given this, generate that particular function which we masked. So one function we won't provide, but based on all this, we want the LLM to generate that particular function. Now we tried it in multiple ways. For example, we said initially it was not about anything. We just said that we want you to generate this particular function, and this is the summary of the code base, for example. So if you go to GitHub, you will have a README, right? README will provide some information like this repository, blah, 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 does something. So we said, can we just provide the repository information and ask it to generate a function, A? Then we said, can we provide the repository information and the summary of the code base to generate, B? Then we said, can we provide the repository information, code base summary, and some functions within the repository to generate a function, 3. Fourth one, we said, okay, we'll provide all this, right? And we also will give you some examples of how the functions have been done in that particular repository. Can you generate this? So we did all that. There is a detailed study design, right? So we have 3 types of abstractions in prompt. We have 4 serverless repositories. So we had a data set of, I don't remember, some thousands of serverless functions. From that, we did some classification. We wanted to pick diverse set of serverless function with most number of stars. And we also, since it is code generation, right? In decision and context, it's kind of relatively easier because you can use this kind of established scores. But in code generation, if you want to really show something works, you have to actually test that it works. So we wanted to only select those repository that has test coverage of at least greater than 70%, right? So we picked all those repositories and we tested 145 functions, serverless functions. We tested manually, we tested in an automated way, right? Using LLMs, how good they are. So yeah, these are the, all the different, aspects that I already talked about. These are the models we picked. We picked Gemini 1.5 Pro for summarizing the code base. Then we have Artigens Coder, CodeQuen, DeepSeek V2. Even before DeepSeek was popular, we had selected DeepSeek Coder, and then GPT-4. These were the models we picked. So we got some interesting results, right? And this might help you if you are really worried whether your job will go or not, right? We have some insights for you. So we understood that. So one thing we did is, once we got the results, we did no intervention and intervention for each type of prompt. When I say intervention, it is going to the result generated by LLM and tweaking few things. Like for example, it would have forgot a semicolon, it would have missed a opening or closing braces, it would have missed passing some parameters. So all this we manually do it. But rest of it is automatically done by LLM. So we wanted to see how much human help is required. And we observed that with intervention up to 71%, DeepSeek was very good, right? Which means that out of 100 functions, 71 functions it was able to generate correctly. It passed all the test cases with human intervention. Interesting results here. I'm not going through all this. So these are code quality, right? We wanted to check what is something, number of lines of code generated by the LLM, What is the cyclomatic complexity? Have you heard of cyclomatic complexity? No? Not going into it. So there is a bunch of metrics by which you can say how good is your generated code. Okay, we went through all that. And essentially the idea is very simple. LLMs did it better than humans. Okay, that's it, period. But we also observed that, as I said, it's not that LLMs were doing everything correctly. So we believe that human architects plus models, right, all these LLMs, plus some developer support is a great combination. So if you know how to abstract things, and if you can provide some good prompts, with a little bit of intervention, they can almost generate the entire code. Yeah, so that's the observation. Yeah, this is also again a published work, right? So we want to do next step, which is very similar to what I showed in the morning. So in the morning, if you see, I showed an example of a microservice-based IoT system where if a person goes to a city, if they don't have a functionality, you want the system to build the application, right? But here what we said is, okay, we want to build the application, but suppose the functionality does not exist at all. I asked for a functionality saying, hi, I want indoor quality in NIT Surathkal. And there is no sensor that is, there is a sensor that is located here, it is sending the data, but there is no functionality that can integrate with the sensor and give you the information. So we said, why don't we use LLMs in this scenario where LLMs autonomously understand that the system does not have that functionality, it builds the code, it integrates the code, it deploys it, everything done automatically, right? And gives you back the response. This is again going back to the autonomous adaptation part. So we integrated this whole concept. So for example, imagine that you are a tourist and you say, hey, I have 3 hours to explore in Hyderabad's old charm, what do you recommend? So it will say that you can visit this place, that place, and it will keep understanding the tourist better and better. Once it understands the tourist, it will say, okay, based on what I have understood, these are the functionalities that you would need. But some of this functionality I don't have, because my code does not have it. So what I'll do for you, I will generate those functionality, I'll deploy it as a Docker container, and I'll serve it to you so that you don't have to worry. So if the user finds a feature is needed, the feature is automatically built, provided there are some ways by which this feature could be built. Okay, so that's the whole idea. So this is the architecture of what we did. We used an agentic AI approach. I don't want to get into it now. I'll come to agentic AI a little later. Where there are a bunch of LLMs talking to each other and generating the code and deploying the code, okay? And we observed interesting results. We observed that we also did a study with some set of users. It's not there yet. There's still a lot of challenges because we are trying to generate not a serverless function, we are generating an entire microservice. So it was difficult, many issues were there, but more or less we felt that where the community is going, these kind of things would be more possible as we go forward, right? Again, subject to the fact that you need human supervision. So there is a website for this. If you are interested, you could go and scan it and you have the working demo of it also, you know how it works and so on. So based on all this understanding, one thing we understood is we don't have enough data sets for software architectural work for LLMs to use, or for LLMs to be tested, or for LLMs to be evaluated. So we created a website called sabench.com. You can go to this website, it's live. Here we have all this work that whatever I've been talking about is here live. We also have a leaderboard which says for each task which LLM performs better than that, and what are the metrics that you need to use. Because many times people ask me, okay Karthik, what are the metrics we should use to evaluate? So you have all that here, right? So feel free to go. This is a community effort. So we are improving it. We are developing further things on this. But we'll be happy if you want to contribute. You can also contribute. You just have to send a pull request to the GitHub and we'll be able to add you. Okay, so the same thing, right? What we asked in the morning. Now we said, we do all this using GPT, right? We said that you could generate components, you could generate functions. So we were doing more at the design level and code generation level. Now we said, what about maintenance? See, one of the biggest challenges, as I said in the morning, is your software system probably might fail and you want a human probably to intervene, understand what has happened and then fix the system. We said, instead of a human, can we use an LLM there? Where you throw in all the data about the system in terms of logs, in terms of what is happening in the system, and you ask the LLM, okay LLM, this is what my system is going through, can you suggest some solutions? Like, my system is under a security attack, there is some kind of intrusion happening, there is a DDoS attack that is happening, what should I do now? And the LLM will try to infer the situation of the system and try to come up with some kind of suggestions. And you want to implement it with the help of a human. But we initially, even though that was the plan, we said let's do without human and see where it goes, right? Because it's research, right? You can do fun stuff, right? So that resulted in a paper like that. We said reimagining self-adaptation in the age of large language models, right? I was talking in the morning about self-adaptation. We said, how do you reimagine self-adaptation concept itself when you have this language models? So that was the whole idea. And this paper interestingly came out of a discussion with a undergraduate student after a class. So I was doing a software engineering lecture. I finished the lecture, I was coming out, and the student comes and says, I think this is a very interesting idea. What do you think? And I said, yeah, we have been thinking about this, but we don't have people to work on this. He said, I'll be happy to work. That resulted in this work. Yeah, and this was published in a Tier A conference. So we came up with this idea. So you remember the MAPE loop, right? We took the same inspiration, but we said, you don't need a monitor, analyze, and plan. But we said, instead of analyze and plan, it should be more like a synthesize, because you're actually synthesizing information based on what you observe, right? So we just changed MAPE to MSE, which is monitor, synthesize, and execute, right? So you monitor all this data, you synthesize information, you have a prompt generation, you have an LLM engine, and then you execute, right? But before you execute, you can probably have a verifier if you are using something like a critical system. I mean, you don't want LLM to do whatever it wants. So you can go back to the approach I said in the morning, maybe use a model checker and so on. Of course, this is something you know, so we implemented this in the swim, right? This is a prompt we use. So we said, you are an adaptation manager, blah, 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 and these are some things you could do. We said you can either increase the add server, you can remove a server, you can change the dimmer value, exactly what I said in the morning. So all that we said to the LLM as a prompt, and we said, okay, now given this situation, what will you do? Okay? And this is the interesting result. So this is using Swim's adaptation, what you saw in the morning, right? And this is just by using GPT. There is only GPT-4 taking the data and it is generating things. And you see the utility graph here. This goes up to 3,500-ish, more or less. This goes up to 2,500. Now we have reached even beyond that. We have reached a point, the latest research that we have reached 4,500-ish close to. Not using GPT alone, we are using a bunch of agents, right? But what we observed very interesting is, there is no exceedance of response time threshold here when using GPT, because it is always trying to optimize that I should only reduce response time. It is not understanding the balance between cost and revenue, right? So it is going haywire there, right? So it's not really sensitive on that. So probably we are trying to see how we can improve, right? We already did some work on this. So the game theoretical or the theoretical optimal for this problem is 5,000 something, which was done using a game theory approach. So what we are able to use with using a combination of LLM agents at this moment is we are able to reach close to 4,500. Right, so which is actually a good result by itself. Anyway, so that's pretty much about what we have been doing from different angles in software engineering space, right? But what we observed off the late, right, as we were doing all this, that's when agentic AI was taking a big prominence. Today, everyone are talking about it. So in 2021, we had done a work where we talked about the fact that everyone talks about using AI, using AI, using AI. But no one talks about how do you build an AI system? How do you engineer an AI system? What are the challenges in engineering AI system? It could be security, performance, all that what we said in the morning. So we said, how do you architect an AI system itself? What are the challenges? One of the biggest challenges, if you look at an AI system, on one side you have a machine learning system, which is very probabilistic. On one side you have a traditional software components, which is more deterministic, where if I put 1 + 1, it is going to give 2. One of the members here, he was asking a question. When I ask this prompt, it is giving a different response now. Why? Right? So we don't know. And Rudra was mentioning it is probabilistic, right? Because you don't have much control on what is the output there, right? So how do you put this team together? Because one team will be like, hey, my concerns are more about testing, security, technology, fault tolerance, blah, blah, blah. Other team is going to be like, oh, I am more concerned about model accuracy, model versioning, data quality, privacy, blah, blah, blah. So putting these two teams together is always challenging, right? So we had listed some challenges on this where we talked about what needs to be done in this field. And one of the challenge was with respect to process. Most of the companies follow an agile methodology in building a software, but machine learning and agile won't go together. So how do you come up with a solution? So we worked with a company, we created something called Agile for MLS. Now what I want to say is, AI systems, engineering AI systems possess a lot of challenges. Agentic AI just adds more to it, right? Because even today the stat says more than 50% of ML systems don't go to production. They are all nice POCs, but they don't really make it to reality because of bunch of problems. Maybe users are not happy, maybe the programmers didn't do it well, bunch of reasons. So we wanted to come from the other side, which is AI for SC, right? And at that time we were working with this company called Monty Cloud, or we started working with them. They had a very interesting problem. How many of you use cloud? AWS, GCP, Azure, anything? Cloud computing. 1, 2, 3, 4, that's it. Okay, 5, great. Is there anyone who does not understand cloud at all? You have some understanding, fair. Okay, so in cloud there is very interesting aspects going on, right? So there are a bunch of providers like Azure, AWS, Google Cloud. It's a big domain by itself today. If I want to build something in cloud, I'll get confused because those many services are available. If you go to Google, Google will say, I have Vertex AI for all your agentic work. I have this, face recognition or something for your image detection task. I have Cloud Run. I have BigQuery. So many things are there. So a person finds it very difficult to understand what to use when. That is one problem. The other problem is if you have built something in cloud, who will tell how good it is? Right? For example, you might have built a nice system on cloud. But for example, you might not have your security, your system might not have been properly encrypted, right? You might be using a file system like S3, but S3 is a storage offered by AWS. In Google, it is called buckets, right? You might use a storage bucket and the storage bucket may not be encrypted. So someone has to monitor all this and tell you, hey, there is a security problem here. You are supposed to pay only $10, but you are exceeding the cost because there is an instance that is just like that running, right? And believe me when I say this, many organizations pay millions of dollars per month as cloud bills. Okay? So the biggest challenge is who is going to be that person who is going to monitor my cloud and tell me that, hey, there are some problems here, why don't you go and fix it? Right? This has been a big challenge. So that is when a company like Monty Cloud comes and says, hey, you know what, we will provide a layer in between. We will ensure that all the, your cloud management is taken care. You just focus on building stuff in cloud. We will take care of all this management stuff. And this management stuff is taken care in such a way that AWS or Google or Azure have built something like, Wafer or well-architected framework. This exists for Azure as well. If you just Google Azure well-architected framework or AWS well-architected framework, you will get a set of guidelines. What this guideline says is, if you want to build on cloud, this is how you have to look at security. This is how you have to look at reliability. This is how you have to look at performance, sustainability, cost. They have put a lot of guidelines. Now what Monty Cloud as a company does is, it will go through all the guidelines, right? So this is the dashboard that Monty Cloud provides. It goes through all the guidelines and says, okay, your cloud is this good, your cloud is this bad, these are the potential challenges you have, why don't you go and fix it? So it provides all these recommendations. Now they came to us and said, hey, you know what, we have this massive amount of data. Can you help us build something like a Copilot that can help the customer footprint, or even someone called managed service providers. So this managed service are the people who go and sell the cloud, right? For example, they will come to you and say, hey, you know what, AWS is a very good thing, why don't you buy AWS? So they will provide this AWS for you and they will help you manage cloud. And for those people, Monty Cloud helps them manage the customers, right? So that's where Monty Cloud comes in. So they said, can we do something for this? And we built initially something called a Copilot. I'm sorry, the demo is missing, but it's a PDF. So we built an initial Copilot where people could ask questions and it will help with answers. Very simple chatbot. That's it at that point. So, but we observed a lot of engineering challenges there, right? One is cloud itself is massive. It contains a lot of data. It contains security data, reliability data, performance data, all this different type of data. And then every customer is having their own way of how they handle with cloud workloads, how they launch instances, when they stop instances, and so on. Then we were finding it very difficult to maintain because our code base was becoming very big, right? We were just using a kind of a monolithic way, one LLM. You bombard all the data to the LLM where we were doing something like a RAG, and that was becoming difficult. We understood that this is not working out because every operational domain within cloud has its own language. So you bombard all the data to LLM is not working. And then of course, we don't also want to the fact that tomorrow we might want to, get some inspirations from, some other person might say, hey, I have something done from my company. Can we integrate this with your tool? And that was also becoming a challenge. So what we figured out was, we said, why don't we, start thinking about agents at that time, right? Again, that time agentic AI was just coming up. So we said, if we can build specialized LLM units that can focus on different domains, it becomes great. That was the whole idea. So that's when I want to just give a glimpse. I'm sure Rudra already did, but still just to touch upon what LLM agents are actually, right, about. So an LLM agent, if you look at something, it's just an autonomous entity that can sense the environment and perform an action. Now what is an LLM? It can predict the next word. Okay? So if I continuously generate the next word, I'll get a text. This was the whole concept. But when it is able to generate text, people started asking if it can generate text. It means that it can say that this is what you have to do. For example, it can say, hey, I am drenched in rain, what should I do? So the LLM will say, go and take an umbrella. Now, the next question that people ask is, if LLM can say that, can we also provide some support for the LLM so that it can actually do that? Of course, it cannot take umbrella for you, right? But can you make LLM also do that with some kind of a support? That's when what they said is, let us add some kind of tools that the LLM can use. So on one side, LLM can come up with some possible actions. And now these actions can be translated by calling one of the tool. It can invoke a tool and the tool can perform the task for you. For example, I want to go back to Hyderabad, okay? Sir booked all the tickets, so that's done. But imagine that I want to go back to Hyderabad and we are planning this trip. Now I want to use a bunch of agents and say that, hey, book a ticket for me to Hyderabad from Mangalore. That's it. I don't say anything. Now as a user, what will you do? You will say, okay, if I have to book, I'll have to possibly understand what this person likes, what Karthik likes. He probably likes, one-stop flight or zero-stop flights. He particularly like this kind of preference for meal is there, right? And I want to also ensure that I offer the best price to Karthik, what kind of price he is comfortable with. All this information I need. And then I have to go through Make My Trip, TripAdvisor or all those websites. I have to figure out and then I have to book and I have to send an email to Karthik saying that, hey, your booking is done. Today it is all possible, right? So I can have an LLM that takes an input saying that, hey, I want to book a ticket to Hyderabad from Bangalore. Then it will invoke a tool like Make My Trip, say that, okay, find me all the deals from this. And once it gets that, it will be like, okay, given all these deals, let me, book a ticket for you. So it will invoke the booking functionality. Once it is done, it will say, okay, let me invoke the email functionality and send an email to Karthik. So all this, can I close it? So give that capability where LLMs can generate text and this text can be further translated to invocations of tools. That's what Rudro showed as an example of function calling. So this basic idea of function calling is all about the fact that I can invoke an API, right? So that's the whole point. So which means the API can be a tool here. Now how that can be called, for that there are protocols like MCP today, right? So we'll not get into it much. This is very similar to a microservice, right? Microservice is an autonomous entity. It performs its own function. It has its own database. Similarly, LLM is an autonomous entity. It senses the environment, performs an action. It has a memory, right? Memory is all the past interactions. I have some idea. You did history today, right? You had some idea of that person. So suddenly if you say, who am I? It will say, who are you? But it might again say that, no, you are now this person, right? So how do I keep track of that? So this is what an LLM agent consists of at a very basic level, okay? Now, how does an LLM invoke a tool? For example, how do I ensure that an LLM can call a tool? For example, LLM does not have a capability to go to the graphical user interface and click, right? But instead it can invoke a function. So how should I write the function in such a way that LLMs can easily call me, right? How should I define the function in such a way that LLMs can easily call me? So that is where you have today something like MCP, right? How do I pass this in the context? There's something called model context protocol. I don't want to get into it. Other thing is, how does an LLM agent communicate to another agent? There needs to be some kind of a protocol. That is where you have something called A2A. I don't know if you had something from Google in the morning about Google ADK, right? One of the things that Google ADK uses is A2A protocol, agent to agent, yeah. This is very again similar to microservices, how two services communicate with each other, right? You have to use HTTP protocol, right? So similarly, what is a protocol here? Okay, so the question that we asked is, can we go multi-agent? Now when multi-agent, it means that if I say improve the security for my production application, oh nicely, I didn't design it this way, yeah? Somehow this is a security thing that I'm talking too much in this session today. But if I say improve the security score for my production application, what happens is there is a CloudOps advisor, right? This is my system here, or a multi-agent entity here. What it does is, it will go to a security scanning agent, understand what are the security threats in my system, right? Then it will probably call specialized tools like Amazon Q, AWS Q, or Microsoft Azure's Copilot and so on, right? And then it will generate a report saying that, hey, these are the findings that I have based on your security. These are the recommendations I have. These are the insights. Probably you should take some actions. And I should also be able to create some tickets in my Jira board saying that usually companies use some Jira or some kind of ticketing system where it will say, do this, do that. This is the action for this particular user. And I also want the agent to go and perform the action. At this point, I can say, I don't want this. I might want a human to intervene. That is up to us. Yeah. So all this is taken care autonomously, right? The whole idea of this company that I'm talking about, Monte Cloud, is autonomous cloud ops. Entire operations of cloud should be autonomous in nature, right? So yeah, so based on this, what we did is, we wanted to use existing frameworks. There were frameworks like Crew AI and Graph, right? But none of this framework helped us because those are very monolithic framework. What I mean to say is that we want capability framework, agentic system using Crew AI. One would have built it using AutoGen, but two of them should be able to be integrated with our system. Right? That's what we wanted to do. So what we did is we created a meta orchestration framework where we could essentially have people building their own agents. Anyone can build agents and they can integrate with our system. Right? That was the whole idea. I'll just put it that way. And we published a paper. Of course, that was the whole idea. Right? We just don't want to keep doing private stuff. At the same time, we also want some research part to it, and we also want to tell the community how easy or how challenging it is. So this was again a best paper candidate at Kine at ICSE, which is one of the best conference in software engineering. So we created this. Interesting thing is we also open sourced, right? We didn't want to just keep it. So you go to this repository, you can actually take this agentic framework, build your own agentic stuff, right? So what the essentially idea was, we have a core engine. In the core engine, we have an orchestrator, which will allow you to orchestrate between different agents that have been there in the agent marketplace. And we have something like an agent registry where you can say that, hey, this is an agent and this is the task that the agents can perform. So every time you want to invoke, you can look at the agent registry and pick the corresponding agent that you want to use, right? And we also have some kind of monitoring and guardrails in place, right? Currently, we are in the process of expanding and implementing more and more features to it. But this is more or less the idea. So in our case, we had agents like a report agent that can generate reports for you. We had a summary agent. We had a static agent which has some kind of a knowledge. You can ask question. It's basically a RAG, and you can get a response, right? You had an API agent which can invoke an API and get you back some responses. So you had different kind of agents. Some examples. From this concept of domain-driven design, it's a fundamental principle in software engineering where if you want to build an agent, you ensure that you build the agent in such a way it is very scoped to a particular domain. So like for example, a security has a bunch of information. So we build something very specialized to security, something very specialized to performance and so on. So currently we are still in the process of building it, but this is the whole idea, right? You build agents which is very specific to a domain. Yes, so yeah, you can go to the repo and you can play with it if you're super interested about it. Okay, I don't know, suddenly this is not working. Yeah. So of course we are researchers, we don't want to say that everything is great just by the look of it. You have to actually evaluate and show empirically that it works. Although we couldn't do a very exhaustive evaluation because it's an industry project, you cannot directly ask some other industry, hey, can I evaluate in your production workload? So what we did is, we had subject matter experts who curated a bunch of prompts, and based on that prompt, we were checking responses, how good the response was, again using all these different scores, and we used our agentic framework, and we were able to see that it was able to perform better. But more thing, I wouldn't say better, but I want to say the practical side of it. The practical side of it, now anybody can build an agent in a very specialized way, and they can integrate into our system. And that can provide very specialized expertise on that particular domain. So that is the more key aspect. It's not about how much it's scored and so on, right? So it is getting integrated into a project. I was in the call with the morning, the team, we have regular calls that where we were discussing what we need to do. So yeah, a lot of work here. But something interesting we did for the students is that we open sourced this. So we did a hackathon in IIIT where this Moya was given. It's called, of course there were some press releases in Deccan Chronicle and so on about this work, and that's the media side of it. But the real side of it and the more realistic side of it is that we actually did a hackathon in IIIT where we had 20 plus teams, so about 100 students participated in the hackathon. They built different types of use cases because Moya was originally built for autonomous cloud ops. We wanted to show that it is also generalizable across domains, right? So we built different things like meme generator that can generate memes based on scenarios you give. Like create a meme that Karthik is giving a talk. Yeah, it might generate a nice meme out of it, right? All this kind of stuff, or mental wellness assistant. Some team build a thing, it's called Meta Solver. You give any problem, it will generate agents for solving that problem and it will solve the problem. So that is like a meta level solution, right? So they did all this. Yeah, but we are also currently, trying to see how we can improve. It's open sourced. There is also a nice blog article on Moya, so you can go and read blog.iit.ac.in/Moya. So if you are interested in contributing, you can fork the repo, you can do a pull request, and we'll be able to consider based on how it is. Yeah. So this is Moya for you. So again, the whole idea was how do you build your own agentic framework. So what I want to say is, it's good to start thinking in agents, right? I mean, for people who are interested in security, one of the interesting areas that is emerging in this side is security in the domain of agentic AI. It's not explored well. A lot of challenges exist. When one agent is talking to another agent, I can inject things and so on, right? So how do I prevent that? How do I prevent different kind of attacks? So there is a lot of interesting work that needs to be done from a security perspective. And not every time you need to build an agent, right? So that is something, sometimes again, as Rudro was showing in the tutorial, right? You just sometimes need an LLM with a RAG capability. I mean, you just don't say that everything is agent, right? Think, how do you want to look at it? So Anthropic wrote a very nice blog where they talk about 3 different things. One is simple chatbots. There's something called workflows where LLMs can call a tool. For example, an LLM calls a make my trip, right? That is one aspect. But there are also back and forth communications, a bunch of agents that dynamically decide what needs to be done in a given situation. So there is a lot of dynamic behavior there. You don't have a control. In an orchestrated flow, you have a particular control. You say, this LLM has to call this tool has to be invoked, and then this LLM has to come with the response. So all this is very orchestrated. But in a dynamic behavior, you don't have that. Agents will keep communicating back and forth saying, hey, I think this is what the person likes. So the other agent might say, no, this is not what the person likes, this is what he likes, right? Like this, they will have a back and forth communication that will come to a conclusion, right? So that is also possible. So yeah, engineering plays the key, and I think, that's what we have already talked about. So if you are really interested, you can read those papers. They are by some of the colleagues in Australia, yeah? So I will just slowly end the talk, but just by giving some brief things. So whatever I said in the morning about model switching, right? We also did that for, LLM models, or sorry, small language models that can be deployed in edge, right? So we had this discussion that was about object detection on vision models, but we also did that for language models, where a user will ask a question, we will decide which LLM or SLM to use dynamically, right? This has been deployed in edge. Again, there was a demo, but that's okay. Along with collaboration with Qualcomm. So we did this in their QIDK kit. So what you see here is a representation of a QIDK kit. It's Qualcomm Innovators Development Kit. So we were given this kit and we deployed it and it was working. We also did something called trying not just LLMs. We wanted to see how good are SLMs. LLMs are great. As Rudro was showing in the demo today, they are able to do function calling very well, right? If you look at the few, I think in the few shot they were performing very well. But we said, what about SLMs? Small models that can run. Someone was asking how good they are. So we performed a study for this as well, but we observed that a lot more needs to be done in this space. So we have a very interesting paper where we did a combination of a little bit of security, responsible AI, and software engineering, right? So we have a person called Professor PK. Some of you might know him. He is one of the key researchers in the space of responsible AI in the country. So where we said, why don't we use prompt injection? Right? We inject different kind of prompts to the LLM, to the SLM, and see if it is altering their output, right? So we observed that yes, it has an impact. And what we did is we also quantized the models and we deployed in a small device and see now how much prompt injection will affect. So this was a study that we did, and now we are continuing to do more studies on this. This was published very recently, so you can go and check it out more. Yeah. So yeah, so this is our effort spanning across all different software engineering aspects, starting from requirements to design, development. Testing is something we have not done much. That's not our forte. We don't do much in software testing. Maybe in future, I don't know. But we have tried to capture. But all these are primarily driven by architectural stuff, not by anything else, right? So yes, again, coming back, if you have not been listening, some takeaways for you. Because I know after a lunch session is always super hard, even if the session is very interesting, or if the person tries to, that doesn't work, because even if I am there, it becomes very difficult because nice food as usual in the lunch, and then snacks and so on. So what I have is some takeaways. I feel that LLMs can be a best friend to an architect if used wisely, especially from software systems perspective. And they also provide a very nice support for effective software engineering, right? We have a lot of problems that today we can address, especially if you want a legacy system to migrate to a newer system, right? That's where LLMs can provide a lot of support, right? Or domain-specific LLMs or SLMs. I think that's a key going forward. Today also, many people are talking about agents from using LLMs, right? But I feel the next step should be using agents using SLMs, where they are very specific to a domain, because if you do that, you can actually have a big impact on the carbon footprint. Not just that, but they are very specialized on a particular domain, right? And it becomes easier for you to run on-prem as well, right? And I think systems thinking is very important. See, gone are those days for all the companies listening DSA algorithms test, we should really rethink if that should be the case to evaluate a person. LLMs are doing great job. They are solving almost all the lead code problems, yeah. Recently, I saw that Gemini 2.5 got a very high mark in IIT JEE, right? It solved all the problems, it seems. Someone was posting, right? So we need to really start rethinking what we need to teach and what we need to learn. Abstract thinking is becoming more important. When I say abstract thinking, if you want to build a system, it's no longer about what language should I program, should I use Java, should I write a function in a particular way, but rather it's about understanding the larger picture. Okay, how should the systems interact with each other? What should be the larger components? How should I think about building this? So that abstract thinking is becoming more important, because only if you can think that, you can instruct an LLMs to do that. Otherwise, there is no point using LLMs, because if you don't know what you want to do, even LLMs cannot help you, right? So that's the whole point. I mean, you should know at least something what you want to do, yeah? So yeah, the future definitely is here. We need more context. How do you capture organizational context is a very big challenge. We are trying to work on that. LLMs will hallucinate. Don't say that LLMs hallucinated. I mean, come on, right? They will hallucinate. They are probabilistic models. There is a very nice saying that all models are wrong. Some are useful. It's by a famous statistician, George Box, right? The idea is don't rely on machine learning models. They will be wrong, but some can be useful. How do you make it useful? You engineer it in a better way so that for your use case, you can make it useful. So that's up to you, correct? Multiple agents collaborating together to help software engineers. I mean, Rudra did a small demo of that, very nice demo, right? So those are definitely possible. There is also a lot of potential support in architecture migration, moving from monoliths to microservice or microservice to serverless, modernizing system. See, today many companies are not thinking about, when I want to use LLMs, how do I make my system LLM, what do you say? Something favorable for LLM. That's very hard, because your systems are built for human consumption, for UI consumption. But in order to make it consuming, ability for consume for LLMs, it's very hard, because you have to make it more text oriented. SE process itself will require more upgrades. The way we build softwares might have to be relooked at, right? So that's pretty much it. I want to thank my team also here, because most of the work that I'm talking about is because of the effort of massive number of students who are working, including my PhD students, master students, undergraduate researchers, research engineers, interns. So I want to thank all of them, because ultimately I can keep bragging about whatever I'm talking here. Credits to them, mistakes are mine, right? So they did a great job. That's why I'm able to present all this. If you're really interested, you could go and scan the repository. I mean, our website link, SA4S, our group's name is SA4S. It stands for Software Architecture for Sustainability. We try to do different works in this intersection of software architecture and AI. Of course, sustainability is at the core of what we do, right? So, and of course, if you are interested in what we do in Software Engineering Research Center, serc.IIT.ac.in, that's a website. We are a team of 5 faculties. We do different research, starting from requirements engineering to software quality to formal methods to human-computer interaction to virtual reality to all this work that I've been talking about, right? So, yeah. So looking forward to get informations from you or emails from you, and that's it. Thank you so much for having me. Again, it was an honor. Thank you.